Have you ever looked at a massive project and just thought, wow, this is going to take forever? Well, what if I told you there's a secret strategy to tackle these huge tasks and get them done in a tiny fraction of the time? It's all about the power of thinking in parallel, and we're going to break down exactly how it works.
So, let's kick things off with a challenge that sounds, well, completely impossible. How in the world could you read a 1,000-page book in just 1 hour? Seriously, think about it for a sec. Are we talking about some superhuman speed reading? Skimming? Nope. The answer is actually way more clever. You see, it's not about reading faster. It's about thinking differently and working together.
Okay, so imagine you're in a book club. Instead of everyone slogging through the whole book, you literally tear it into chapters. You give chapters 1 through 10 to your first friend, 11 through 20 to the next, and so on. Everyone reads their little section all at the same time. This really simple divide and conquer idea, well, it's got a very powerful name in the world of computing.
It's called parallelization, and the core idea is exactly like our book club. You take a huge job, like reading a book or, say, processing a massive data set, and you split it into smaller, independent chunks. Then you hand those chunks off to multiple workers, who could be people or computer processors, and they all get to work at the same time. You know, when you look at it step by step, the logic is actually pretty simple. First, you split the job. That's our book. Second, you process all those smaller jobs in parallel. That's everyone reading their own chapters. And third, you have to merge all the results back together into one final output. But here's the kicker. The hardest part isn't the parallel processing. It's actually what comes next in that third step. Just think about it, right? When your book club members hand you their summaries, one person might have written bullet points, another wrote a full paragraph, someone else just jotted down messy notes. They're all in different styles. Before you can combine them, you have to normalize them. You have to get them all into the same consistent format. That is the hidden challenge of parallelization.
So, how do you even keep track of who did what? Well, in computing, there's a term for this. You generate provenance. It's basically like creating little footnotes for your data. It cites which piece of the final output came from which specific worker. This is so useful for tracking and fixing things if they go wrong. Okay, so now let's see how this idea scales up from our friendly little book club to tackling some of the world's biggest data challenges. This strategy is absolutely everywhere. It's used for processing massive data sets, running time-sensitive financial models, scraping thousands of websites at once, and even automating super complex research. I mean, anytime you have a big job that you can break down into smaller parts, parallelization is your best friend. So you might be thinking, okay, that sounds like a lot of work. Splitting, merging, coordinating. So why go through all that trouble? Well, there are two huge benefits. First up, specialization. You could have one worker that's amazing at processing text and another that's a genius with numbers. You can assign tasks based on their strengths, making everything way more efficient. And second, scalability. And this one is the real game changer. Is your job still running too slow? The solution is simple. Just add more workers. The whole system is built to grow. But, just like any team project, more workers can sometimes mean more headaches. And right there, that's the fundamental trade-off. The biggest downside is the added complexity. Managing all those workers and then trying to unify their different outputs into one single perfect result, well, that's a pretty significant challenge. It definitely requires some careful planning. And this whole concept really illustrates a universal question, one that goes way beyond just computers and data. So the next time you decide to split up a task, whether it's at work with colleagues or just planning a trip with friends, you're actually practicing parallelization. And it leaves us with a final thought to chew on. When is the incredible speed you gain from teamwork really worth the complexity of managing it all?